everyone, a warm welcome to the third part of complex integration by Cauchy's integral formula for derivative. I explain how to apply Cauchy's integral formula for derivative in part 1 and its link is. So before watching this video, you have to watch this video. Cauchy's integral formula for derivative is integral over c f z by z minus z naught raised to n plus 1 dz is 2 pi I by n factorial fn of z naught, where this fn of z naught is the nth derivative of f at z naught. Here f z is an analytic function within and on a simple closed curve C, and z naught is a point within C. So for applying integral formula for derivative, we have to choose z naught, n and f z. Then for getting the value of the integral, you have to multiply fn z naught by 2 pi I by n factorial. In certain questions, there is one and only one singularity within C. But in some other integrals, you can see there may be more than one singularity within C. But we can apply this result only for exactly one singularity within C. In this video, I am going to illustrate how to apply Cauchy's integral formula for derivative for the evaluation of complex integrals with exactly one singular point within C. Let me illustrate it. Here we have to evaluate the integral over c, z plus 1 by z raised to 4 plus 2i z cubed dz, where c is the unit circle. First you have to notice its singularities. Clearly its singularities are, see the given function is z plus 1 by z cube into z plus 2i. Clearly the singularities are 0 and minus 2i. Among these two, only 0 is inside of c. So we have to keep z naught as 0. See, the corresponding singular part is 1 by z cube. Its power is 3. So here we have to apply Cauchy's integral formula for derivative since its degree is or its power is 3. If it is greater than 1, you have to apply Cauchy's integral formula for derivative. So you have to choose z naught, n, f z. N is 2. You less 1 from 3, that is 2, that is our n. f z is the remaining portion of the given function. It is z plus 1 by z plus 2i. Our Cauchy's integral formula for derivative is that is 2 pi I by n factorial. What is n? n is 2, 2 factorial. f2 at 0. f2 dash 0 means you find the second derivative of f, then you put z equal to 0. So next we have to find second derivative of f. What is first derivative of f? See, it is a quotient. So its derivative is that is, z will cancel each other. See, the numerator is 2 plus I minus 1 by z plus 2i the whole square. See, this is f dash z. Next f2 dash z. You can find f2 dash by two methods. Either by considering it as a quotient, or you can consider f dash z as, see, numerator is a constant. So 2i minus 1 into z plus 2i the whole raised to minus 2. Next we apply derivative of x raised to n is n x raised to n minus 1. So its derivative is 2i minus 1 into minus 2 into z plus 2i the whole raised to minus. Take this negative inside of this function. So it is 1 minus 2i into 2 z plus 2i the whole raised to minus 2. So f2 dash 0 is 2 into 1 minus 2i into 2i the whole raised to minus 3. That is 2 into 1 minus 2i by 2i the whole cube. That is 2 into 1 minus 2i by 2 cube into I cube. That is minus I. So it is 1 minus 2i by minus 4i. This is our f2 dash 0. You put in our equation. So it is 2 will cancel. I pi into 1 minus 2i by minus 4i. And it is, you take this negative here. So pi into 2i minus 1 by 4. See, this is the required answer of the given integral. Next, we have to evaluate another integral. Integral over c, z square by z cube minus z square minus z plus 1 dz. First, along the circle, mod z plus 1 equal to 3 by 2. And second, along the circle, mod z minus 1 minus I equal to 1 by 2. See, in this question, most of the students make mistakes at many places. So, be very careful answering this question. First, you have to notice its singularities. You can find its singularities by solving the denominator equal to 0. Then you can see its solutions are 1, 1 and minus 1. If you solve by calculator, you can see calculator shows only two values. They are 1 and minus 1. See, since it is a third degree, one solution is repeated. So, by solving calculator, you have to identify which solution is repeated, either 1 or minus 1. For that, you have to use the result. Sum of solutions or sum of roots. Roots is equal to coefficient of minus z square. Here, coefficient of minus z square is 1. So, sum of the roots is 1. So it's clear 1 is the repeated solution. So that its sum is 1. If minus 1 is repeated, then its sum is minus 1, which is not correct. So the repeated solution is 1. So the singularities of the given function are 1, 1, minus 1. So we can factorize the given function as z minus 1 the whole square into z plus 1. Next, you consider the first circle, that is mod z plus 1 equal to 3 by 2. See, in this circle, minus 1 is inside. What about 1? When you put 1, then mod 2, which is greater than 1. So 1 is outside of C. You have to choose the inside singularity as minus 1. And the corresponding singular part in the given function is z plus 1. And its power is 1. So we have to apply Cauchy's integral formula. Here there is no need of applying integral formula for derivative. So in integral formula, you have to choose z0 and fz. So if fz is the remaining part, that is z square by z minus 1 the whole square. By Cauchy's integral formula for derivative, integral over c fz by z minus z0 dz is 2 pi I f of z0. That is 2 pi I f of minus 1. What is f of minus 1? It is 1 by minus 1 the whole square. It is, sorry, when you put z equal to 1, it is minus 2 the whole square. That is 1 by 4. So it is 2 into I pi by 4. That is I pi by 2. So the answer of the given integral with respect to the first circle is I pi by 2. Next, we have to evaluate along this circle. See, in this circle, clearly 1 is inside of C. What about minus 1? When you put minus 1, it is mod minus 2 minus I, and it is root of 4 plus 1. It is root of 5. Root of 5. Here it is 3.14 by 2. Root of 5 is, root of 4 is 2. It is greater than 2. So it is greater than 3.14 by 2. So minus 1 is outside of C. See, the given function is this one. This function has two singularities, 1 and minus 1. Only one is inside of C, the other one is outside of C. We always choose the inside singularity as Z0. So here Z0 is 1. And the corresponding singular part in the given function is 1 by Z minus 1 the whole square. And its power is 2. So we have to apply Cauchy's integral formula for derivative with n is equal to 1. Here we have to choose fz. Fz is the remaining part. It is z square by z plus 1. Integral formula for derivative is integral over c fz by z minus z0 raised to n plus 1 dz is 2 pi I by n factorial fn at z naught. That is 2 pi I, n is 1. So f dash z naught. Here z naught is 1. Next we have to find f dash 1. So f dash z is, see it's a Cauchy. That is 2z square minus z square. It is z square plus 2z by z plus 1 the whole square. So it is f dash 1. F dash 1 is 3 by 4. So 2 pi I into 3 by 4. That is 3 I pi by 2. So the given integral is 3 I pi by 2 along the circle mod z minus 1 minus I equal to 3. Next we have to evaluate integral over c e raised to z square by z into z minus 2I the whole square dz, where c is mod z minus 3I is equal to 2. You consider the given function. Its singularities are 0 and 2I. Clearly 0 is outside of c. Because you put z equal to 0, mod minus 3I, that is 3, which is greater than 2. And clearly 2I is inside of c. So here one singularity which lies within c. You have to choose that singularity as z naught. So here z naught is 2I. So the corresponding singular part in the given function is, see our given function is e raised to z square by z into z minus 2I the whole square. Corresponding singular part is this one. And its power is 2. So we have to choose suitable f. Here n is 1. Next we have to write fz. Fz is the remaining portion of the given function, which is e raised to z square by z. So here we have to apply integral formula for derivative. It is integral over c fz by z minus z naught raised to n plus 1 dz is 2 pi I by n factorial fn of z naught. That is 2 pi I, n is 1, so f dash 2I. Here we have to find f dash z. See it's a quotient. Denominator square upon denominator into derivative of e raised to z square. What is derivative of e raised to z square? E raised to z square into 2z minus e raised to z square into 1. That is 2z square e raised to z square minus e raised to z square by z square. In the numerator, e raised to z square is a common term, so you take it outside. Next you put z equal to 1. Sorry, z is equal to 2I. So f dash 2I is equal to e raised to 2I the whole square into 2 into 2I the whole square minus 1 by 2I the whole square. What is 2I the whole square? 2I the whole square is 2 square into I square. What is I square? It is minus 1. So it is minus 4. So it is e raised to minus 4. 2 into minus 4 minus 1 by minus 4. That is e raised to minus 4 into minus 8 minus 1 by minus 4. That is e raised to minus 4 into minus 9 by minus 4. So it is 9 by 4 e raised to minus 4. You put in this equation, here integral is 2 pi I into 9 by 4 e raised to minus 4. That is 9 I pi by 2 into e raised to minus 4. This is the value of the